All right, here's how you graph the piecewise function from problem 13 in our practice quiz for 14216. And what I'm going to do here is I'm going to make XY tables for both functions kind of independent of each other. Okay, so the first thing I'm going to do is make an XY table for the negative x squared plus 4 function. And I'm going to choose x values in the domain they're giving me. So I can choose x values greater than 1, and I am even going to include 1 in here. Okay, I'm going to include 1 in my x values I'm choosing because what I'm going to do with that, it will be an open dot on my graph. So it's technically not in my domain because it'll be an open dot, but I still do want to graph it. Okay, so what I do then, once I have my x's, which again I'm choosing greater than 1 and including 1 with the open dot, I'm going to start plugging them in. So I get 1 squared is 1, the negative makes it negative 1, plus 4 makes it 3. 2 squared is 4, the negative 4, plus 4 is 0. 3 squared is 9, the negative makes it negative 9, plus 4 is going to be negative 5. And then 4 squared 16 becomes negative 16, becomes a negative 12. Now I'm going to make my xy table for the other function, which is 2x plus 1. And again, I'm going to choose my x's according to the domain that this function can get graphed on, which is x less than or equal to 1. So again, I'm going to include 1 in this and then anything less than it. So 0, negative 1, negative 2. And this time, 1 is really in this domain, so I can graph it in this xy coordinate and actually use a closed dot on it. So I'll have an open dot for the 1 on this one, but then a closed dot for the 1 on this one because 1 is included here and 1 is not included in the first one. So let's start, let's first plug in our x values, see what we get as y's. 1 times 2 is 2, 2 plus 1 is 3, 2 times 0, 0 plus 1 is 1, negative 1 times 2, negative 2, plus 1 is negative 1, and you can see the pattern. I'm going down by 2 every time, and that's going to repeat. So the y values are 3, 1, negative 1, and negative 3. Now I'm going to start graphing them, starting with this xy table up here. The first point is 1, 3, so I go over 1, up 3, and that is my open dot point. Let me draw that circle a little bit better. That is my open dot point because that 1 here is really not part of our domain, but I still want to graph it, so I graph it with that open dot. The next point is 2, 0, so I go over 2, up 0, so that point there. And that's a closed dot because it actually is in this domain, so I can use that closed dot. And I can use a closed dot for the rest of them as well because they're all in that domain. So I can go over 3, down 5, so right here. And then I can go over 4, down 12, which is somewhere out here. I shouldn't really even graph that point, but just to get the view of it. And that is the first part of my piecewise, so just graphing that xy table. The next one I need to graph, okay, 1 is going to be included in this function, so that's going to be a closed dot this time, so I got to go over 1, up 3. Kind of looks funny, but now that's a closed dot because that point now exists in our piecewise. All right, and then I can graph the rest of them, 0, 1, so over 0, up 1, negative 1, negative 1, and then negative 2, negative 3, and I have my second part of this piecewise. Now, I haven't graphed it well, but what we have here is half of an upside down parabola from this function because the upside down parabola is coming from right here. So where it was an open dot going down to the right, that's half a parabola. But then we stop at this point 1, and it picks up actually a straight line going to the left. Now, you can't see it very well in my handmade graph, but if you were to graph these two functions in Desmos, you would get a better picture of it. Okay? But the big idea here is creating 2 different xy tables for each function. Include these points, like this one was 1 and 1. Include those in both functions anytime you see this, and just make sure the ones that are strictly greater than or strictly less than, you use open dots for. Anytime you see less than or equal to or greater than or equal to, you use a closed dot for those. Okay, hopefully the video was helpful. If you have any more questions, I can try to address them to hopefully help out understand these kind of problems.